Every airplane window has a tiny hole near the bottom. It's so small that most people never even notice it. But once you do, it's impossible to ignore. At first, it looks like a manufacturing mistake. Some people think it's there to let fresh air in. Others believe it's there to stop the window from fogging up. Both sound reasonable, but neither is the real reason. That tiny hole exists because without it, airplane windows would have a much harder time surviving every flight. Here's why. When an airplane climbs to cruising altitude, the air outside becomes incredibly thin. At around 35,000 feet, the outside air pressure is only about a quarter of what we experience at sea level. Humans can't survive in conditions like that, so the cabin is pressurized to keep everyone safe and comfortable. But creating that comfortable environment also creates an enormous pressure difference. The air inside the cabin constantly pushes outward against the aircraft's fuselage, including every single window. Each window has to withstand thousands of kilograms of force every time the aircraft reaches cruising altitude. If airplane windows were just a single sheet of plastic, they would quickly become a weak point. Instead, every passenger window is built as a carefully engineered system made from multiple layers, each with a different job. The outer pane is the one that does almost all of the heavy lifting. It's designed to withstand the massive pressure difference between the inside of the cabin and the outside atmosphere. Behind it sits a middle pane, and finally the inner pane, the one passengers can actually touch. Most people assume all three panes share the pressure equally. Surprisingly, they don't, and that's exactly where the tiny hole comes in. That tiny hole is called a breather hole, and despite its size, it quietly controls how pressure is distributed across the entire window. As the aircraft climbs, air becomes trapped between the different layers of the window. If that trapped air couldn't move, pressure would build up between the panes, forcing multiple layers to carry loads they were never meant to handle. Over thousands of flights, that extra stress could shorten the window's lifespan. The breather hole solves this by allowing the air between the middle pane and the inner pane to equalize with the cabin pressure. That means the middle pane no longer has to fight against two different pressures at once. Instead, almost the entire pressure difference exists between the outside air and the outer pane, the strongest layer of the window, specifically engineered to handle that force. In other words, the tiny hole isn't there to make the window stronger. It's there to make sure the right part of the window carries the load. That's an important distinction because modern airplane windows aren't designed so every layer shares the work equally. They're designed so that one layer, the outer pane, takes almost all of it, while the other layers serve different purposes. The middle pane acts primarily as a backup. If the outer pane were ever damaged, it can temporarily help maintain the pressure until the aircraft lands safely. The inner pane, meanwhile, isn't the pressure barrier at all. Its main job is to protect the layers behind it from passengers, scratches, and everyday wear. So even though you're sitting just a few centimeters away from it, the pane you can touch isn't the one keeping the cabin pressurized. And the tiny hole helps make sure it never has to. But the breather hole has another useful job. During a flight, the temperature outside the aircraft can drop to around minus 60 degrees Celsius. While the cabin stays warm and comfortable, that huge temperature difference can cause moisture to collect between the window panes. The breather hole allows a small amount of air to circulate between the inner layers, helping moisture escape instead of becoming trapped inside. This greatly reduces the chance of fogging or condensation building up where passengers can't wipe it away. That's why, even after thousands of flights through freezing temperatures and changing altitudes, airplane windows usually stay remarkably clear. It's easy to assume such a tiny feature couldn't matter very much. After all, it's just a hole only a few millimeters wide. But in engineering, size doesn't always determine importance. Sometimes the smallest components are the ones that quietly make the entire system work as intended. Remove that tiny hole, and the window would experience pressure in ways its designers never intended, while moisture would also have a much harder time escaping. It's a simple solution to two very different problems, one involving pressure, the other involving condensation. And that's exactly what makes it such an elegant piece of engineering. The next time you sit by an airplane window, take a closer look at that tiny hole in the corner. It may look like an insignificant manufacturing detail, but it's actually one of those features that only exists because engineers spent decades learning how to make aircraft safer and more reliable. Without adding complicated electronics or moving parts, that tiny opening helps control how pressure is distributed across the window, while also reducing the chance of moisture becoming trapped between the panes. It's an elegant solution because it doesn't fight the enormous forces acting on the window. It simply guides them to the part that was designed to handle them. Instead of making every layer stronger, it makes sure each layer performs exactly the job it was built for. That's often what good engineering looks like, not adding more, but making every component do exactly what's needed. Every commercial airplane repeats this process over and over again. During each flight, the cabin is pressurized after takeoff and depressurized again before landing. Over the lifetime of an aircraft, that can mean tens of thousands of pressurization cycles, with every window experiencing the same demanding conditions again and again. Yet despite all of that, millions of passengers look through these windows every single day without giving that tiny hole a second thought. It's always there, quietly doing its job, flight after flight, year after year. It's a reminder that some of the most important pieces of engineering aren't the biggest or the most expensive. Sometimes they're the ones almost nobody notices. And once you know what that tiny hole does, sometimes the most extraordinary things are hiding in plain sight. You just have to look twice.